Hey, what's up, guys? It's Nicola from Calcunic, and today we're going to talk about multiplying polynomials. Let's get right into it. So in this video, we're going to go over a bunch of examples regarding how to multiply different types of polynomials, and we're obviously going to get progressively harder in the examples. But let's start off with something easy. Let's say we are asked to find 3, or just to expand, 3 times x plus 5, right? How do we solve this? Most of you probably already know. What we want to do is take the 3 and multiply it with x and also with positive 5. But why do we do this? The reason is because we are taking the 3 and we are multiplying it by this entire expression. And so therefore, we're not only doing 3 times x or only 3 times positive 5, we're doing 3 times x and also 3 times positive 5. So this process looks like this. We do 3 times x, and then we do 3 times positive 5. And that is going to give us our final answer, 3x, and then 3 times positive 5, that's positive 15. So 3x plus 15. Now this is pretty straightforward. Let's use this same logic to move on to some slightly harder problems. Let's say the question is to expand 2x minus 1 times 3x and then plus 4. How do we do this? Well, in this question, we have slightly more terms than in the question above, so this might get a little more complicated. And to help us keep this problem organized and not messy, we use this acronym called FOIL. Basically, FOIL tells us the order in which you want to multiply the terms in the two expressions to help us keep track of everything. So first we have our firstmost terms, and that is going to be the 2x and the 3x, the first terms in both expressions. So we're going to multiply these two first, 2x times 3x. Our next step is to look at the outer terms. The outermost ones are 2x and positive 4. That's to the left and to the right of the entire expression. So next we're going to do 2x times positive 4. The next two to multiply are the innermost ones, and that's pretty self-explanatory. That is negative 1 and 3x, the innermost terms in the expression. And then we go on to the last two of both expressions, so negative 1 and positive 4. So enough talking, let's actually solve this question. So the first thing we do is multiply the first ones, 2x times 3x. And what does this give us? Well, first we multiply the coefficients or the constants, 2 and 3. That is going to give us positive 6. And then we have just x times x. And basically what we do when we multiply two numbers with the same base is we add their exponents. And when we write just x, that's the same as saying x to the power of 1, and we also have x to the power of 1 here. And so we want to add these two exponents. 1 plus 1 is 2, so 2x times 3x is 6, and then we have x squared, or x to the power of 2. Next, we multiply the two outer terms, 2x and 4. 2x times 4. And this dot just means multiplication, not to get confused with anything else. 2x times 4, we multiply the constants, 4 and 2, we get 8. And then we have the x term from before. Next is the innermost terms. We have negative 1 and positive 3x. So we write negative 1 times positive 3x, and their multiplication is equal to negative 3x because the negative 1 makes the term negative, obviously. And finally, we have the last ones, negative 1 and positive 4. So negative 1 times positive 4, and the negative 1 just makes this negative, so we write negative 4. All right, perfect. Let's write these out in order. So we have 6x squared, then plus 8x, and then minus 3x, and finally minus 4. And so we have our expanded expression, but there's a little more we could do to simplify this. We take a look at like terms. In this case, the like terms are 8x and negative 3x. Like terms just mean terms that have the same exponent on x. In this case, we have x to the power of 1 and also x to the power of 1 here. So we're going to add the coefficients on these terms. This expression then becomes 6x squared, stays the same. And then we have 8x minus 3, that's positive 5, so plus 5x, and the minus 4 from before doesn't change. So there we have our final answer, 6x squared plus 5x minus 4. Let's move on and do some more examples. Our next example is asking us to simplify 7x minus 4, and then times 4x plus 5. How do we do this? Once again, we are going to invoke the FOIL method. So first we do the first multiplication. We have 7x times 4x, the two first terms in both expressions. 7 times 4, that gives us 28. And then we have x times x. and that gives us x squared. Next, we multiply the outermost ones, 7x and 5. We have 7 times 5, that is plus 35, and all that remains is the x term. Moving on, we have negative 4 times negative 4x. Negative 4 times 4, that's negative 16. And then we have the x, so negative 16x. And finally, we have negative 4 times plus 5, and that just gives us negative 20. All right, perfect. We have successfully expanded this expression. Now what remains is to group like terms. We have the plus 35x here and the minus 16x, both of which will contain x to the power of 1. So we're going to group these two terms. We have 28x squared, and then plus 35 minus 16. 35 minus 16, that is positive 19. So plus 19 and then x, and we're left with negative 20. So there we have it, 28x squared plus 19x minus 20. Let's try a slightly harder example now. We're going to multiply a binomial by a trinomial. We're going to do 3x minus 2 times x squared plus 4x and then minus 1. How do we solve this? Well, unfortunately, we can't use the FOIL method anymore because FOIL is just for when we're multiplying two binomials. But we could still apply a very similar logic. First, what we want to do is multiply 3x by x squared. So we have 3, the constant, so 3 here, and then x times x squared. We add the exponents, 1 plus 2, giving us x to the power of 3. We then move on to 3x times 4x. 3 times 4, that is plus 12. X times x is x cubed. And finally, we have 3x times negative 1. And that is going to give us, what, 3 times negative 1? So negative 3. And then, of course, the x from before. We move on to multiplying with negative 2 now. Negative 2 times x squared. That's pretty easy. That's just negative 2x squared. Then we have negative 2 times 4x. Negative 2 times 4, that is negative 8. And then we have the x from 4. And finally, we have negative 2 times negative 1. When you multiply with two negatives, that makes it positive. So we get positive 2. Positive 2. Now we have our expanded expression. What we want to do is group the like terms. We have like terms in 12x squared minus 2x squared. And we also have another set of like terms in negative 3x and negative 8x because they both share just the term of x. So let's now write this final expression. We have 3x cubed. That doesn't change. We have plus 12x and then minus 2x squared. The 2x squared terms, 12 minus 2, that's plus 10. And then we have, of course, x squared. Then we have negative 3x and negative 8x, the two x terms. So we do negative 3 minus 8, that is negative 11, and the x. And then we have plus 2. So plus 2, leaving us with our final answer. So to end this video, we're going to do one last example where we're going to multiply two trinomials. Let's say we're given x squared plus 3x minus 4 times, 4x squared minus 9x, and then plus 6. And we're asked to expand this expression. And so when we have these longer expansion questions, it's really important to keep everything organized and to be very clear with what we write. Otherwise, things get messy, and that leads to easy mistakes. So enough talking, let's actually do the math here. We have x squared times 4x squared first. So that is going to give us 4, and then x squared times x squared, that is x to the power of 4. The next multiplication is x squared and negative 9x. We have negative 9, the lone constant, and then x squared times x, giving us x cubed. Finally, we have x squared times plus 6. So we write plus 6 and then x squared. We move on to multiplying with the 3x term. We do 3x times 4x squared. And I'm just going to write below so we don't get crammed up towards the right. 3 times 4, that is 12. X times x squared, that is x cubed. Next, we have 3x times negative 9x. 3 times negative 9, that is negative 27. And then x times x is x squared. And then we have 3x plus 6. 3 times 6, that is just positive 18. And then we have x. Now we go on to our final set of multiplications, that with -4. This is where it might get a little messy, but I'll do my best to be clear. We have -4 times 4x squared. -4 times 4, that is -16. And of course we have x squared. -4, then we have times -9x. We have two negatives, they cancel out. 4 times 9, that is 36. So we write 36, and then we have the lone x term. And finally, we have -4 times +6. -4 times +6, that gives us -24. And now we have our final, very long expanded expression. What we want to do now is take a look at all the like terms and then reduce them accordingly. So we have like terms in -9x cubed and also +12x cubed. We also have like terms with 6x squared, -27x squared, and also -16x squared. So 3 like terms there. And finally, we have +18x and +36x to work with. So instead of just adding these in your head, I would recommend when the numbers get bigger, as they are here, to write it out on the side so we don't make any simple, silly mistakes that might lose us points on tests. First, we have -9 and +12. So we're going to write -9 plus 12. -9 plus 12, that's easy. That is just +3. We then go on to the white coefficients with the x squared term. So we have 6 minus 27 minus 16. So we write 6 minus 27 minus 16. If you're on a test and you have a calculator, definitely use a calculator to make sure you don't make any mistakes here. But if not, you could just solve it in your head or on paper. 6 minus 27, that is -21. And then -21 minus 16, that is minus 37. And finally, we have the yellow coefficients corresponding with the x term, +18 and +36. So we have 18 plus 36, and that is just +54. And so we have all three of our like terms grouped up, and we have their final coefficients. Let's go ahead and write out the final expression. We have that all of this is equal to 4x to the power 4. And then in red, for the x cubed, we have +3x cubed. In white, we have minus 37 for x squared. And in yellow, we had +54 for the x's. And then here we have minus 24, so minus 24. And we get our final expanded expression. Alright guys, thank you so much for watching. If you had any questions about the video or just other video suggestions, drop them down in the comments below. I do try to get to all of them. And if you made it this far, leave a thumbs up if you liked it, and subscribe if you loved it. That's all for me. Until next time.